Yeah, my name is Josh Weissbock, and this morning I'm speaking on high fidelity web crawling in Python. If you need to contact me or want to contact me after, you can find me on Twitter at Josh Weissbock, where I'm always talking hockey, sometimes Python and a lot of running. My email is also on my bio there. So I want to thank PyData for letting me speak this morning. I'm feeling a little bit of imposter syndrome here because I spent all yesterday listening to a lot of awesome talks, and I feel a lot of people are doing really awesome applications and giving a lot of awesome presentations, and everything's way above what I'm doing, at least what I'm feeling. Today I'm speaking a little bit more on the technical side. I am wanting to share with you guys my lessons that I've learned from taking Python scripts and turning to something that are more robust, that you can trust and run routinely. So what that means is Python makes it really easy for you to scrape the internet. But those simple scripts aren't something I would trust to run on a routine cron job on a server to collect thousands of web pages on a routine basis. And this is just something I've learned from my experience in my work and what I'm going to share today. So just a brief outline. I'm going to talk to you briefly on Python web scraping. Should be pretty familiar. I'll talk some of the issues that come with it, and then I'll just get into the basic lessons I've learned. They can be described at a high level as logging, dealing with dynamic web pages, so dealing with JavaScript, and navigating barriers, so when websites just don't want you to be scraping them. So to give a little background on myself so you know where I'm coming from, my name is Josh Weissbock. By day, I work for the Canadian federal government in the Department of National Defence in Victoria, BC, where I'm a communications manager. At nighttime, I moonlight in the National Hockey League. I do data analytics, so basically Moneyball. I work with the Florida Panthers, specifically on their amateur scouting team. So our job is to try and find 17 and 18-year-old kids who will someday hopefully play in the NHL, so we can draft them and have exclusive rights to deal with contracts with them. I started getting to Python and hockey way back in 2006, 2010, when I was studying computer science up in Simon Fraser University in Vancouver. That's where I really got introduced to Python, the basic concepts of Python, and the basics that I use today. It's also where I started to really get into hockey. From 2012 to 2014, I moved out east to Ottawa, Ontario, where I did my master's in computer science at the University of Ottawa, and I studied machine learning, natural language processing, and I was actually doing my thesis based on hockey analytics. And part of my thesis work required collecting data every day, so I could actually perform my experiments and complete my thesis and graduate. Part of that was using Python, where I had scripts running every day to collect routine data, and that's where I really started to learn some of these lessons and run into some of these issues. And that ultimately ended up getting me hired by the National Hockey League in 2015. That with some public research I had on the hockey blogosphere. And as part of the team, one of my main responsibilities is handling the entire data pipeline for our team. So I'm the main person responsible for the collection of data, for the validation, verification data, for the storage and presentation, visualization, and when I have some time, I work with the other analysts to actually convert our stats into cross-domain language so that the traditional scouts can understand, we can have a conversation in the same language. So if you've ever done any type of data science course online, you'll find the very first thing that they always do is they give you a very nice data set. The iris one is a very common example. So right away you have this great data set, you start analyzing, you start working on it, you start asking questions with it, but that's not the reality within the real world. You end up finding 80% of your work is just getting the data and getting into usable state. There's a great talk yesterday on rowing, and the presenter ended up explaining this greatly. Most of his work was just trying to get the data into a usable format from scraping. He was having issues with, and the same thing I deal with in hockey, where you can't trust the data you're getting. You'll find examples such as player birthdays are wrong, heights are wrong. You'll never find a 5'11" hockey player on the internet. And then once you actually get your data, you need to actually analyze it. And that's the final step, but most of the work is actually getting it. So really my talk here again is focusing on the very first step of getting your data, and that's the collecting. So this is a very simple example of how to scrape in Python. If you've done any type of work like this before, it's pretty familiar. There's a lot of great built-in modules with Python, requests, URL, lib, and simply you feed it a URL. That URL can have daily reports that could be updated daily and that you want to collect information from. You pass it to the requests module, and then you pass it to your parsing function. The parsing function can do whatever you want it to do. A common example would be to use something like beautiful soup, and hopefully not regex, to parse the HTML, find the information that you need, store it, and then return that the function was successful. So really in this talk, I care about lines 5 and 7. I don't care what the function is doing, I just care about getting the HTML to the function and that the function worked. And that's really where we're going to focus today. So that script is great. It's great if you want to run it on your terminal, you write it, quickly code it up, execute it, grab some data, you're good to go. But that's not a script I would trust to run on a server every day at 2 a.m. to grab data from a bunch of different websites, especially when you're not just grabbing one page, you're grabbing hundreds of thousands. The internet by its nature is ugly. It's held together with duct tape. Things don't work the way they should sometimes, most of the time. You have network connectivity issues, servers might be down, your internet connection might be down, and there's a number of issues that can actually cause you to fail, your script to fail. And that's where these lessons really came into play. So, scripts can fail for a number of reasons in Python. This is probably the easiest and simplest lesson, but it's probably one of the most important. Websites can change. All of a sudden, the website you're scraping has a new layout, your parsing function fails, and you're not able to collect data anymore. Maybe their server doesn't work. Maybe your internet connection doesn't work. You need to be aware of these failures on your scripts before your users spot it. There's nothing more embarrassing as a data manager than when your user's coming to you telling you that your data is out of date. So the very solution to this, you need to be alerted. Python makes it easy in a number of ways for you to know when your script fails. You can email yourself with something built in such as smtplib, or you can use text or SMS with Twilio. But more importantly, you need to know what went wrong. Again, you can use built-in features such as the logging module to capture all kinds of relative data, or important data. You need to know what websites failed, when they failed, any input parameters. You need to know what part of your script failed, so you can try and debug what went wrong. And importantly, you also need to know what went wrong on the website. Did they give you a 200 error, a 403 error, a 404 error, a 500 error? So you can kind of figure out whether it was the server's problem, whether the server blocked you, or whether something went wrong on the server. So that one's very quick, very easy, but it's very important. Something that's kind of built into the next 3 lessons. Looking next forward is dynamic websites. Traditionally, our internet was built on static HTML. Those are super easy to scrape in Python. But now we have a large rise within JavaScript frameworks, React, Angular, Ember, etc. All of these load up an HTML page. The JavaScript then dynamically generates the content and loads it into the web page. This makes it really difficult for Python to scrape on its own using requests or URL lib. What you see in the browser won't be necessarily what Python sees. And sometimes reverse engineering these JavaScript APIs isn't the most resource friendly. Like I said, if you're reverse engineering 100,000 pages, you probably don't have the manpower to do that. So the solution to that is Selenium. A lot of you probably use Selenium for testing, but it can also be used for generating, for web scraping websites. You can combine it with Phantom.js, and now you have a headless browser you can actually use to dynamically generate execute the JavaScript, so you can actually load the content on the pages you're trying to scrape. Phantom.js is actually shutting down right now. The author has given up on the project due to the rise of Chromium. So that's going to start shifting toward Chromium rather than Phantom.js. But there are a lot of different alternatives, such as Firefox, VFB, Scrapey, and Splinter. So what that looks like in Python is just swapping out your requests module with Selenium. I use the Phantom.js web browsers. What I would use, again, you feed it the URL in the same method. Now your browser can grab the HTML and you can pass the function. but you're still going to run into problems with this. Again, poor network connectivity, poor servers, poorly designed websites, and all the other issues that come up with the internet can hinder loading of the JavaScript. Timeout issues are a common one where it just takes too long and Selenium gives up and grabs what it has, which is an incomplete web page, which means you won't have all your content, which will cause your parsing function to fail. There are a couple ways we can actually address this. 3 solutions I kind of came up with, starting with the ugliest, which is simply use the time method. I'm sure you can see the problem with that, but we'll get to that in a sec. But basically what you do is you're loading up the web page and you tell your script to wait a certain amount of time for the JavaScript to load, and then you grab the content. This is a very crude method because you don't know exactly how long it's going to take the website to load the JavaScript content. You can be waiting too long, so now you're wasting resources and processing time. So if you're doing 100,000 pages, your scraping function go from 2 hours to 72 hours. And vice versa, you can get the opposite, where you're not waiting long enough and you're running the same situation where you're still not loading the content. So then the solution to that is Selenium has a great expected conditions built-in function. It basically tells the browser to not move forward until a certain condition is met. So basically when a certain element is loaded. The common one I love to use is CSS selectors within HTML tags that I know should be on the page. And you also give it a certain amount of time to sleep for. So it will wait 15 seconds, as an example, until the CSS element's loaded. As soon as it's loaded, we'll continue forward. If it hits 15 seconds, we'll give up and move forward. And that's the issue. So that was improvement on the time, but it can still fail. If the website is poorly designed, which happens in the real world, you're still going to fail at grabbing the content. We also require known CSS selectors, whatever other elements you want to select from the web page. So kind of the solution I came up with that, it's not pretty, but it's effective. Basically, you're trying until you're passed. You're going to throw that same code into an infinite loop, and you're going to keep trying until it gets a web page. You want to have some sort of check so you're not spinning forever, because there can be legitimate reasons why it can't load, such as the website no longer exists or the server may be down. So you want to do some sort of, what I would do is give it a max attempt. So basically you're saying you're going to keep trying this to request this web page, pass it to the parsing function. If it fails, we'll try again. And if it fails 10 times, then we're going to log that error. You're going to alert yourself as a data manager that something went wrong, log it, and move on. This actually works pretty effectively in some of the use cases that I've came across it with. So it's ugly, but it's simple. It does work. It's easy to implement. You can combine it with the expected conditions, so you're waiting the optimal amount of time, hopefully. And you can even add a time delay between loops just to give it some, so you're not hammering the website with requests. And again, logging and alerting is required. The first lesson that we learned. You need to know when something broke and why it's broken. So that kind of leads into the third lesson. Websites may not want you, and if you keep hammering them for requests, you're going to DDoS them. So you kind of need to throttle your own scripts. Websites might not want you for a number of reasons. So it's kind of an ethical question whether you should be scraping them, and that's up to the individual person. You should be respecting your neighbors on the internet. You shouldn't be hampering their resources, and you should be respecting robots.txt. Ideally, websites would have some sort of API you get scraped from, but again, this is not always the case. But sometimes as a data manager, you need your data for whatever your project is. So you need to find these solutions that prevent your crawlers from detecting that you are crawling them and blocking your IP. The very simple solution, create a proxy server. For those who don't know, a proxy server is basically a man in the middle. You're feeding your request through. Your computer goes to a secondary computer who requests the resource, goes back to the middleman, and then goes back to you. This can be done really easily. Requires simply spinning up a VPS, or you can use, I prefer DigitalOcean, but you can use Linode, Amazon, Google, the old computer you have in your closet. You just need another computer to act as a middleman. When you're using a lot of these VPS services, you can actually use their APIs, so you can actually continue to make this autonomous, so you don't need to be creating a VPS by hand every week when you're running the script, or every night when you're running the script. And creating a proxy server is really technically it's easy to do. That SSH command, you just identify which port you want to be feeding your request through, and you have a proxy server in one line. Now you can forward your request through this proxy that you just created. You can test it from any other terminal. Just send a curl request through your SOC S5 connection to the IP that you know from your VPS through the port that you've created, and you should be able to request the website. If this works, you can now feed this into your Python script or have a man-in-the-middle request your resources for you. But the trick here is you don't want to use just one proxy. So, example of what I would be doing in real life, I would create anywhere between 2 and 5, normally 3 proxies. I create them as a list. I know their IPs, I know the ports. And again, on every request, all you do is you pick a random proxy and you feed it into into the key arguments within the request module, and Selenium can do this similarly. And now you're requesting rather than your server is requesting the resource, you have a man in the middle requesting for you. And by randomly doing this, you're constantly hopping, so the requesting server will not be able to easily detect that one person is crawling them. But it doesn't end just there. You have to change your headers and your user agent. So it appears that different physical devices or different browsers are requesting the resource from the requesting server. You have to be a bit careful here because different websites react differently to the user that's requesting them. So you'll notice that when a mobile device loads up a web page versus your computer device, you may get different content, so you kind of experiment with that. So the default is the bottom line there. I'm not going to read it out. But that is important because if the requesting server has any type of detection or crawling detection, and it notices the same header repeatedly requesting resources from their machine over and over and over, even from different IPs, it may trigger that their bot detection. So to try and eliminate that issue, what I do is I have a text file, about 900 different legitimate headers. And you can find these on Google, just a quick search. And really, same thing as the proxies. You load up the list, and every choice, along with selecting a random proxy, you select a random user header. And same thing as the proxies, feeding as a keyword argument to requests, you also feed the headers. So now it looks like different devices on different machines are requesting the server. And that just leads into another issue. All of a sudden you're slamming their device, and again, you gotta slow down these requests so you're not DDoSing them, again, being a good neighbor. And also, it's going to easily trigger any type of bot detection if the server notices the same 3 IPs, even with different addresses, are hammering them with the request very quickly. That doesn't look like a normal user's requesting. So you need to put some sort of timer in between requests. A simple solution being just a random sleep between every request, between 1 and 5 seconds. And all of these combined will hopefully make it look like an actual user's loading up web pages versus a script. And again, you still need to log this in case your scripts break. You need to know if all of a sudden one of your IPs is banned, and you need to know what went wrong. So combining all 3, it makes it really easy to hide yourself as a bot or a scraper crawling looking for resources. Improves your chance of succeeding, but the problem is now it's going to be really slow. Again, I use the real life example is I have a script where every week I need to scrape out 100,000 pages, and I found myself going from 2 hours to 72 hours. So, but on the other hand, if you don't do that, you're going to be banned and you can't crawl the resource. So it's kind of it's an internal discussion you have to have of how important it is to scrape and what you need to scrape and when you need to scrape. So just to wrap up the 3 lessons learned, like when your traditional scripts in Python are really easy to grab resources from a website. But to put into production onto a server that routinely requests from resources, whether it's one page or 100,000 pages, and whether it's daily, weekly, monthly, you have to put some redundancies in there can make sure this script can keep going. First one being logging. You need to be aware if something breaks so you can address it right away, and you need to know how it broke so you can actually debug what went wrong. The rise of JavaScript has made things more difficult within Python scraping, so you need to be able to handle JavaScript created content, and you can do that easily through the use of headless browsers, but you still need to address the issues that arise from poor websites. So you need to put redundancies to keep trying, even when the internet doesn't want you to. And the final one is just bot prevention, how to get your scripts around crawling on the internet. So if a website, how to get around bot detection. So basically the use of proxies that you want to randomly generate through the use of user headers, so you can look like different devices are requesting, and throttling it so it looks like it's more naturally, humans are naturally requesting it. So none of these are really elegant or beautiful, but like I said, they're very simple and they're effective. And I found in my years of using them, it greatly allows me to trust that the scripts I'm creating are going to grab the data that I need every day. So I'll turn it over for questions. That was quick.
So what sort of data are you scraping from these websites? Like are you doing it for the Panthers?
So I'll give an example. Yeah, hockey data, player data. Within the Panthers, like I said, we're dealing with amateur scouting, so we're dealing with players across the globe who are 17, 18. There's thousands and thousands of leagues, and within those leagues, there's thousands of players. So it's constantly getting up-to-date information on players across leagues, so we can have a breadth of knowledge of who's out there and who's succeeding.
And then how do you are those URLs, like how do you get a list of all those URLs to just run through?
The easiest one is, in my case, I use one website that has a whole bunch of all the information across the league. So the standard URLs, the URL is pretty similar. So you can go on the first page and you get a list of the leagues, and from there you can figure out the IDs for the leagues and keep traversing downwards. So leagues will have teams will have players, and then you can go on the player pages.
Excuse me. I'm curious if you have any advice or anything that you've learned building more generic scrapers, as opposed to like building a scraper for like one site to pull off structured data. That's one thing. Building a scraper that's going to go across multiple sites, even if it's just doing like article extraction or like content extraction from pages. Do you have any like tools or libraries that you've had experience with that are particularly good at that kind of generic approach?
I would suggest something more like Scrapey, which is, I haven't used it myself, but I know it's a tool that makes it easier for a wide array of websites to scrape from. So it's not within my, my scope of experience.
So it sounds like you're recommending Phantom.js over Chromium. Is that just kind of the way you presented that slide? Have you used both? And do you have any reasons to use one over the other?
I probably missaid it. So I've been using Phantom.js since I've been doing this. Phantom.js is going to be shutting down. I believe it has. So it's going to be transitioning toward Chromium. I'm still using it just as legacy because it's within my code. I don't have too much experience with loading Chromium, but as it gets more mature, it's something I would suggest using over Phantom.js.
Yeah, so another problem with the dynamic sites. What's about navigating in the sites? Is there also possibility to do this with PhantomJS or other tools you use?
I would say it requires a combination of domain knowledge, so you have to have an idea how the website's structured, but using headless browsing, you can still load up the content and navigate it in a similar fashion.
Do you have any recommendations for scraping on single-page apps where the URL might not change as the page view changes, and it just becomes more difficult to navigate your crawler?
It's kind of a similar answer. Again, it requires domain knowledge. So scraping is very context specific. You have to know what you're going for. So a lot of these I would imagine would be similar in terms of the techniques to solidify your script, but you still require knowing, that goes a bit into the function of actually parsing the page, of knowing what's on the page, how it's written, how it's built. So that's.
You mentioned about using proxies, and I was wondering, the proxies might shield you from detection in terms of the identity of the source of the scraping attempt, but does it also shield you from? Well, there are web servers that are clever enough to map IP addresses to specific geographical locations. Does the proxy, protect you against that? So if I have a web server that tells me, well, even though these are different IP addresses from which this requests are coming, but they're all coming from the same location, geolocation. So that could, to me, indicate that, this is a clever attempt disguised as from multiple sources. How does it work in that environment?
It's not something I thought of. I can see where you're coming from. The solution I would think of there is, so for example, in the case I use DigitalOcean, when you create a VPS, you can specify where it's coming from. So you can specify which data center. So you could either, if you want them all in the same region, or you could diversify them, so depending again on the context of what you're trying to handle. So I would say create your VPSs based on geographical locations that depend on the context of what you're looking at.
So this is cool. Do you have a success story? I mean, who's the player that you found from scraping that none of the other teams could find?
I can't speak too much on that, but so we're a little bit off topic. So we're not data, like our decisions aren't based purely on the data. It's a combination of both the qualitative and quantitative analysis within the players. And we find the players that are best are players that we all agree on. We just had the draft 2 weeks ago, and in the 6th round we got a player named Alexi Repo. He plays in Finland, and he's a bit of an older player. He's a player that we identified a couple years ago, and a player they hadn't really watched, but we kept pushing. It's like, watch this guy. So they watched him this year. They liked him, and we ended up drafting him. So that's probably a good example where our work came in to look at the breadth of players to try and pinpoint players we think require further analysis, and the traditional scouts came and did further analysis on their end, and combined we're like, yeah, this is a good bet.
All right. If there are no other questions, let's all give Josh a round of applause for the great talk.